So today we're going to look at interest. We're going to look at simple interest and compound interest and then continuously compounding interest. This should all be stuff that you've already covered in either Algebra 2, maybe even in Algebra 1. So this should feel really familiar, but we are going to do just a refresher on what all these different things are. Okay, so first off, I want to talk about, before we get into the formulas and stuff, what's the difference between simple interest and compound interest? Okay, so here's the basic idea. Say you have just, we're going to use some easy numbers here. So say you invest $100 into an account, and for the sake of making our lives easy, we'll say that we're doing a 10% interest rate. Okay. So when you put this money into your account with simple interest, what they do is they say, okay, so you invested $100. So you start out with $100. Okay. And then, sorry, I sneezed. And then I sneezed again. Good story. Okay, so then what they do with simple interest is they say, okay, well, 10% of $100 is $10. So we're going to pay you $10 in interest, and now you're going to have $110. Okay. And then the next time that it comes time for you to get interest again, whether it's the next month or the next year or whatever, right? They say, okay, well, you put in $100 and 10% of that is $10. So now we're going to give you another $10 and you're up to 120. And then the next time around, they say, well, you put $100 into your account, 10% of that is $10. So we're going to add another $10 to your account. Now you've got 130. Okay. So basically, the idea of simple interest is that whatever money you put in, that is what the interest is calculated off of. Okay. But what you can kind of look at when you think about this is you could think to yourself, well, wait a minute. I'm up to 130 bucks, right? If I were to withdraw this money and then redeposit it into the account, when they calculate that 10% interest, now I'd be making $13 instead of just 10, right? So wouldn't you be better off withdrawing your money and putting it in to start over so they'll recalculate your interest, right? That would make you more money, right? That is exactly what compound interest does. Okay, so simple interest, you only earn money off of what you actually put into the account. But with compound interest, you earn money off of the total amount that's in the account, whether or not you were actually the one who deposited it or if it was something you earned in interest. Okay, so with compound interest, you earn $100, right? So then they say, okay, well, 10% of that $100 that you have in there is $10. So now you're up to $110. Okay, so far it's the same. But then they say, okay, well, now you've got $110 in your account, and 10% of that is $11. So we're going to give you $11 in interest, and now you're going to be up to $121. Okay. And then they're going to say, okay, well, now you're earning 10% interest. Well, 10% of this is about $12. So we're going to add in $12. So now you're going to be up to $133. Okay. So simple and compound interest, they start out pretty much the same, right? But over time, having compounding interest is going to make a big difference. It's not really that big of a difference right now. It's only $3, right? But over time, it makes a huge difference to have compounding interest versus having simple interest. Okay. And imagine if, say, instead of $100, right? Imagine if instead we had deposited $100,000, right? Well, then over here, sure, we're at $130,000 now, right? Over here, now we're at $133,000. So now instead of just being a $3 difference, it's a $3,000 difference. And that's a lot more significant, right? So you're going to see the differences a lot more when you have a larger amount of money or a lot of time. Okay, so that's the general difference between simple interest and compound interest. Okay, so let's talk simple interest, right? Where they calculate it just based off of the first amount. So your interest is calculated on just one time based on the initial amount. No initial additional deposits are made. Okay, so what that means is that, like, when you put money into this account, you don't continue adding money. So like if you have a savings account, like you might say like, oh, I'm going to put $100 a month into the account. That doesn't happen in simple interest. You just put the money in once. There's no repeated payments at all. Okay, so some real life examples, because this sounds like it'd be stupid, but it is something that actually shows up. So when you take out any kind of like loans, like a car loan or a mortgage or like most student loans, Okay, when you think about that, you say you borrow $1,000, right? Well, when they calculate your interest, they don't say, okay, well, $1,000 at 10% interest is $100. So now you have to pay us, interest based off of $110,000. Okay, they don't calculate it like that. They just calculate your interest based off of how much money's in the account. Okay, so you do see simple interest showing up in real life situations. Usually it's a little bit more complicated than just the example that we did on that little scrap of paper, but you do see it. Okay, so basically what the idea is here's your formula to find the final amount, right? The accumulated amount. You start with your principal or your starting amount, and you multiply it by 1 plus your rate times time. Okay, so the general idea, right? If we kind of think back to what we did here, was we said in our original problem, we said it was $10, right? So we multiplied the rate on, oh, okay, this formula is set up a little bit differently. But the idea is that you calculate how much money it is, and then you basically just multiply it by time, right? And that's sort of the idea of what's kind of happening with this formula. It's written out a little bit differently. Okay, so let's look at an example. So our bank pays simple interest at a rate of 8% per year for certain deposits. If you put $1,000 in, you don't make any withdrawals. So we're not trying to make this complicated. So you don't make any withdrawals, leave it there for 3 years. What's the total amount at the end of 3 years, and how much interest have you earned? Okay, so first of all, key phrase, it tells you that it's simple interest. That's how you know it's simple interest. Okay, so it'll kind of come right out and tell you if it's going to be simple interest. All right, so we want to know the total amount at the end of 3 years. So we're going to calculate our final amount is our principal, which is $1,000, okay, times 1 plus your rate. Make sure you write that as a decimal, so 0.08 instead of just 8. Oops, sorry, no parenthesis yet. And then we're multiplying that by the time, which is 3 years, okay? Make sure you follow order of operations when you do these. So you're going to multiply the 0.08 times 3 first. So 0.08 times 3, add the 1 to that, and then multiply that by $1,000. So 1240. So our final amount is going to be $1,240. And then the question of how much interest you earned. Well, if you put in $1,000 and you're walking away with 12,004 or 1,240, then your interest earned would just be $240, right? You just subtract how much you put in compared to how much you have total. So nothing too complicated there. Okay, so that's the idea of simple interest, right? 3 years, you don't make all that much money. All right, now compounding interest is the other example. So compounding interest is when they recalculate how much money you earn every time. Okay, so your interest is recalculated every period. Okay, so we say period because sometimes, depending on what the loan is or what the amount that you're investing in, whatever it is that you're looking at, sometimes it might not be every year, it might be every month or every day, or something like that. Okay, so it gets recalculated. So like, for example, your credit card loans are calculated daily. Okay, so it depends on what the setup is. So that's information they'll give you. They'll tell you what the period is. So your new interest amount is based off of the previous balance, including any earned interest. Real life examples, credit cards, like I said, are a big one. Retirement accounts, if you're saving for retirement, and sometimes student loans. Student loans can kind of vary. So we're not going to talk too much in depth about how student loans work, but that's it. Just sort of depends on what the way the loan is set up. All right, and your formula is a little bit different. A is still your final amount. P is still your principal or your starting amount. 1 plus, and then R is your rate again. And you're dividing by n. N is how many times a year you are compounding your interest. Okay, and it will tell you that somewhere in the problem. You'll see in just a minute. Okay, n, notice that shows up again. So the n shows up in 2 spots. You're going to reuse that number. And then T is how long it is that you're saving. Okay, usually that's in years. So let's look at some examples. So we're going to set up one problem, find the accumulated amount if after 3 years if you invest $1,000 at 8% per year, and then we're going to compound it a bunch of different ways. Okay? So notice that it's the same setup as this problem. We're putting in $1,000 at 8% interest for 3 years. So we can kind of look at what the difference is going to be. All right, so if we're compounding our interest annually, that means they just reevaluate your interest once a year, right? So we're going to say it's A equals your starting amount, $1,000, times 1 plus the rate, which is 0.08. And if we're compounding annually, annually means once a year. So our n value is going to be 1. So we're using n equals 1 when it says annually. And then it's raised to the 1 times 3 because it was 3 years. All right, so the ones kind of simplify things a little bit, right? I would add 1 plus 0.08 divided by 1 is just 0.08. And when I add 1 to that, it's 1.08. So that simplifies a little bit. And then 1 times 3 is just 3. So that's pretty easy. And then multiply that by 1,000. So that's going to work out to 1,200. I'm just going to round to the nearest dollar for the sake of simplicity. So we're going to call this $1,260. Okay, so $1,260. So when you compare these two, you can already see we're making more money. All right, compounding semi-annually. Semi-annually means that you're doing it twice a year. So this means n equals 2. So our setup's going to be almost the same, right? We want to find the final amount. Our starting amount's $1,000. 1 plus my interest rate of 0.08, but now we're dividing that by 2, and we're raising it to the 2 times 3. All right, and you just got to be a little bit careful when you put this in your calculator. So 0.08 divided by 2, if you can't do that in your head, then add the 1. And then when you raise it to the exponent, you have to be careful, okay? Because if you type it in like this, you're going to get the wrong answer. Okay, so your two options are 1, put it in parentheses, or 2, and this is what I usually do. It's usually a pretty easy multiplication. 2 times 3 is 6, so just put 6 there instead. Do that calculation in your head. It'll make your life a little bit easier. All right, and then I'm going to multiply that by 1,000. So that works out to, again, round to the nearest dollar, $1,265. Okay, so you can see we did earn a little bit more money compounding semi-annually instead of just annually. All right, quarterly, like there's 4 quarters in a dollar, right? So that's 4 quarters in a school year. So that's when you have n equals 4. So it's going to be initial amount times 1 plus our rate. That part's not changing because we haven't changed that in this problem. But now we're dividing by 4, and it's going to be raised to the 4 times 3. So again, calculator. You can do all this stuff in parentheses all in one go if you want to. That's fine. Order of operations will work out for you there. Raise that again. Do that calculation in your head. Raise it to the 12th power, not 4 times 3. And then times 1,000. So that works out to $1,268. All right, compounding monthly. Monthly, there's 12 months in a year, so that means we're talking n equals 12. So our final amount, $1,000 times 1 plus 0.08 divided by 12, raised to the 12 times 3. Okay, and again, you should have done this before, so this shouldn't feel like anything too major or new. So I did the inside parentheses, raising that to the 36th power, multiplying that by 1,000. That works out to $1,270. All right, and then our last one, compounding daily, which again, this is how credit card interest works. Credit card interest compounds daily. We're going to talk about that more later. So 1,000 times 1 plus, and daily is off of 365. So, whoops, I put that in the wrong spot. 0.08 divided by 365. And then it's raised. I can't quite fit it to the 365 times 3. Kind of ran out of room there, sorry. So 1.08, nope, sorry. 0.08 divided by 365 plus 1. Raise that. I can't do 365 times 3 in my head, so I'm going to go ahead and do parentheses around it. Okay, again, if you don't include the parentheses, you'll get the wrong answer. So make sure you do that. And then multiply that by 1,000. So that works out to $1,271. All right, so that is the idea of compounding interest. So what I want you to notice from this is notice that the more times you compound, you earn more money, right? The biggest difference is from not compounding to compounding once. That's where you're going to see the biggest difference. Okay. And then from there, though, if we look at the difference, right here, we went from 1 to 2 compounding periods and we gained $5. Here we went from 2 to 4 and we only gained $3. Here we went from 4 to 12 and the difference is only $2. And then we went from 12 compounding periods to 365 and we only added $1. Okay. So does it make a difference if you compound more? Absolutely. Okay. But there's a limit to how valuable compounding is. Okay. So there's a point that you're approaching here that's the most amount of money you could make, right? Like we could break this down even further and say like, well, what if we compounded it like hourly, right? Would we make more money? Yeah, you would, but it's not going to be that much more money. Okay. Because there's a limit to what you're approaching to what the max is. Okay. And that limit is at continuously compounding your interest. So instead of saying, let's compound it every hour or every minute or every second, we say, well, what if you continuously compounded your interest? If your money was just always compounding based off of how much was in there. Okay. And that's the next type of interest we're going to look at is continuously compounding interest. Okay. So interest is being continually reassessed based on the current total value. And your real life example is like a bank account. When you put money into a bank account, this is what they do. Okay. They don't want you to have to go through the hassle of constantly withdrawing your money and putting your money back in. So they just continuously compound your interest. And you're going to notice that the formula is very different here. So this is APERT is how a lot of people name it. All right. E is a value on your calculator. So when you look on your calculator, on these ones, for example, if you have a graphing calculator, it's above the division symbol. I don't know if you can really see that too clearly on here, but above that division symbol right there, there's an E button. It's a lowercase e. You don't want the one that looks like 2 capital E's. You don't want the one that looks like 1 capital E. You want this guy. Okay. You could also use over here above the LN button, there's an E to the X. That's the same E. It just automatically puts it in exponent form for you. I usually don't use it, but you certainly can if you want to. All right, so this one, we got the same problem, and we're actually going to skip the compounded daily, and we're just going to go ahead and find compounding continuously. Okay, so if we compound this continuously, we use this formula instead of the last one. Okay, so it's going to be A equals your principal amount, $1,000, times E, which is that calculator number, and it's raised to the interest rate times time. Okay, when you put this in your calculator, so I'm going to do $1,000 and then times E, so I'm going to hit second and then the division button. And then when you raise that to your exponent, again, you've got to either multiply that in your head or put it in parentheses. Okay, so make sure you do that. Okay, so rounded to the nearest dollar, it works out to $1,271. Okay, so when you compare, right, on the last one where we did daily to this one, rounded to the nearest dollar, it's the same amount. Okay, if you actually looked at like the decimals on these, this one is technically a little bit more money, but it's really not substantial. It's not even enough to round us to the next nearest dollar. Okay, so there is like benefit to compounding your interest, but there's a limit to how valuable it is, and continuously compounding is the limit. Okay, and in real life, it just really depends on what kind of thing you're looking at, whether whether or not you're looking at what type of the account is. It depends on how it's setting up your interest. Okay, so like I said, like a credit card is daily compounded interest. You don't get a choice in that. That's just how it is. Okay. When you put money into your bank account and they continuously compound it, you don't get a choice in that. Like, it's not like you get to go pick your bank account and say, oh, well, this one's continuously compounding and this one's only daily compounding. Like, you don't get the option. It usually just is what it is. All right. So that's the idea of compounding interest. Okay. One more quick thing to note. All of these things, simple, continuous, and continuously compounding interest, they're all based on a one-time payment or deposit. Okay, we're going to talk later about something called an annuity, and those are based on multiple payments or deposits. So this is the idea that, like, you win the lottery and you stick your money in the bank account once. Okay, we're going to look at later, well, what if you just start putting like so much money into your account every month? So if I decide I want to save $500 a month, or I want to deposit $1,000 a year. So that kind of idea where you're doing repeated payments, that's something different. Okay. So all of these examples that we just talked about, they're based on a one-time deposit or a one-time, like it might be like a loan or something, or like a purchase, but it's all based on a one-time thing.